Yeah, we'll be stepping into machine learning bit by bit with this topic. So this particular topic is the last tool that we will need to build machine learning model. It's a very essential tool because it is going to fast track some data analysis process and the building of model. So it's very important we grab this tool along with us as we start building our machine learning model from next week. But this class is not going to be so theoretical. We will not be dealing with a lot of theory on the board. Mostly what we do today is to code it out, explain some basic concept and code it out. So we are not going to be dealing with theory, and I hope we'll get along with it. So we will be talking about Numpy and Pandas. Some of us will have seen it before, but I will just paraphrase what it means. Can I continue? Yeah, I'll just paraphrase what it means. Numpy, it's a short form of the word numerical Python. So Numpy is very important when we are dealing with numerical computation. Anything that has to do with mathematics or any kind of complex computation in Python, because Python language is not as fast, is not that optimized compared to languages like C++ or Python or Java, sorry. So the only way that we can do some complex calculation or that can make it very fast is using Numpy. Python does not have some inbuilt data structure that we have in other languages that I mentioned before, like array, for instance. The only way that Python implements array in its language is using Numpy. Just know that Numpy is called numerical Python, and what that means is that Numpy is a library that is used to implement numerical Python or calculation or complex calculation in mathematics. That's what it's used for. So with the concept of pandas, pandas is built on Numpy. Numpy primarily is built from array. It is the implementation of array. Array is what is being used in other languages like Java, like C++. They all call array. We explained the concept of something that can look like array in our previous slide. We talked about list. List can also be likened or compared to an array. Okay, but pandas is built on top of Numpy. So before you can understand pandas, you have to understand Numpy. Pandas is mostly two-dimensional. It is fast, it is powerful, and then it helps in data wrangling, data analysis, or anything that has to do with data. It's a table format. We are going to implement some of them, and you see it in picture. I'm sure if you have done data science courses before, you have used pandas before. So let's keep moving. So Numpy, as we have been doing so far, we like to represent our concept pictorially in picture form. So Numpy can be represented in three formats. The basic one that we have probably talked about before is the one that looks like list. List is a one-dimensional, data structure. List can be one-dimensional or two-dimensional. We use the two. But we can have Numpy, which implements array to be one-dimensional. It's like you are storing the item in a rectangular shape object. So the one-dimensional, we have it 1, 2, 3. It's just going to be in a square. In a rectangular shape item, you are storing the item in them. So if it is two-dimensional, we are going to be having a table, which is going to be having a row and column, which can also be likened or compared to matrices, row and column, a table, row and column, which we implemented in our last class. Then another third structure that we can use Numpy for is the three-dimensional array data structure. If you are the type that find yourself working on complex problems in deep learning, for instance, specifically convolutional neural network, CNN, you are going to be dealing with unstructured data, like images, for instance. If I take a picture of myself, for instance, and that picture is white and black, let's say it is white and black, it is not colored. In computer vision, we say this type of picture has one channel. because it is just white and black. It's a gray color. Yeah, we call it gray. The color is gray. But in the case that I take a picture with a phone and I have the output to be colored, if it is colored, any picture that you take, if it is colored, it has three color channels. It has three channels, okay? And the three channels, they are called pixels. Pixel. If you are dealing with computer vision, you understand this better. But these three channels, every picture you take, they are actually numeric number embedded in them. And that numeric number that is embedded in them can be represented with Numpy array. And that's the three image color that you can see here. If you have any image that is colored, it is always in three image color, which is red, green, and blue. And that's another function of Numpy. It is used to represent very complex pattern in computer system. So these are the three structure of Numpy. That definition, you can read it on your own. It's just the same thing that we have been explaining since. So let's move on swiftly. So we are going to be dealing with some implementations now. And most of them, we will just jump into our laptop and start coding it. You can follow along. And if I need to write anything on the board, I will come right to the board. So let's start with this. I would like to switch to my Google Colab platform. You can follow along. I'd like to switch to my Google Colab. I think I have closed it. Let me just search for it. Google Colab. That's bad. Okay, we are here. So the first thing we are going to be implementing is this. We are going to be creating, let me see it like this. I think so. So we are going to be creating a Numpy array. It doesn't matter. We are going to be creating a Numpy array. And we have said that the Numpy array is created with, it's built on top array. It's the implementation of array in Python. So how do we create it? The code is there, but we just try to implement it. So let's say we want to create this array. Oh, it's gone. So anyway, I will write the code. So the first thing we have to do is that for us to use a Numpy array is a library. We have to first import the library. So by saying import Numpy as np. Now the reason why we normally use this type of import statement is because of the documentation of Python. If you want to import a library, you can import it using a short notation. np you can use any other thing aside from np. You can even use num, but standard wise we use np to represent numpy. So this statement imports numpy, and we can use every method in that package. Now, in programming language, if you have done anything that has to do with object-oriented languages before, like Java or C++, when you talk about package or library, the meaning of that is this package contains some method that you can use. You can call the method from this package to complete some tasks. Maybe I want to do some addition, I want to do some multiplication. These are methods that are implemented in this package or in this library. So before you can use this method, you have to first import the package. That's the first statement here. So I want to create a simple numpy, array that will just create a simple number array. Let me just have it here. We have num, and I'm creating it from a list. You can create numpy from a list. I have 2, 3, 4. Then after that, then I can say print. This is a list. I can say print numpy is equals to num np dot array equals to num. I'm using the same thing. Let me use my list here so that it will be different. And I'm using my list here so that it will be different. Now what am I doing here is that the first thing I did was to create a list. We have talked about lists in our previous class, and that's you can see there. Now, for me now to create a NumPy array with this list, then I'm going to be creating with this NumPy NP, and I'm going to be calling a method or a function from it. The function that I want to use to create this NumPy is array function, and that is the array you can see there. Then I'm passing to it that list. Then I store it in a variable. Then I can print it out to see what happens. Then I can say print num. Let's see. I don't think it's printing the way I want. Is it? Let me see. Come in. The type of num. I want to check something. Yeah, it's a NumPy array. Yeah, it is. So, in short, I have created a NumPy array with this structure. And that's the first implementation. Anytime you want to create a NumPy array and you have a list, just put that list using this method, np. The reason why I can use this method is because I have imported this library. So let's move to another one. Our class is going to be pretty, simple today. Let's move to the next one. Now, this one too, apart from using array method or function to create a NumPy, we can also use another function that we call arange. Let me go back to now. In our list class, we talked about range. And range, what did I say we use range for? Range is to list numbers within a particular range. If I want to get number from 1 to 10, I can use range to start from 1 up to what? 10. Not 10. 11. Because the end number has to be one number ahead so that you'll be able to get that array. It is the same understanding that we have to use for NumPy, but we don't call it range in NumPy. We call it a range. A range. Just put a at the front of it. So let's assume that I want to get number from 1 to 10, like we have said now. It's going to be 1 to 111. We are going to have the start number, the end number, and what? And the increment, of course. If you want to put increment that is not 1. By default, if you don't put any increment, it's going to be increasing by 1. But let's assume that I want to create even numbers now. From between 1 and 11, it's going to be, I'll be increasing it by 2. You understand what I'm saying? If I say, okay, let me just write the first one so that I will not confuse. Let me write the first one, then we'll talk about the second one. Let me write the first one. Let's say I want to create number from 1 and 10. A range of number. So I will say, I'm creating number, and the number is going to be, you are going to use np. The np is the library of NumPy. Then you can say dot. If you want to call a method in a function, a method in the library, we use dot. These are all the methods that you can use. You can see hard, you can use absolute, you can use all. It's not everything that we'll be using. You can use minimum, you can use maximum. These are all the methods you can use. But you don't necessarily have to cram everything. You just know it as you use them. So the one I want to use now is range of number. So we have a range. And that a range is going to have the start point, which is 1. The end point, which is 11, because I want to take 10. And if I want to put increment, I will. But if I don't put increment, this is just going to give me number between 1 and 10. Because it's going to be increasing by 1. So let's print it out to see what happens here. One, 2, 3, 4, and so on. So let's now assume that I don't want the number to be given as increment of 1. Let's say I want the number to be given as increment of 2. Then I can just say, okay, comma, I can put a third argument there. I can put 2 here. I can put 2 here as a third argument. Let's print it out again and see what happens. So we start with 1. Don't forget that the 1 has to start. Then it's going to be increasing by 2. 1 plus 2, that's 3. 3 plus 2, that's 5. 5 plus 2, that's 7. And 7 plus 2, that's 9. It can't go to 11 because the last number is 10. Then it can't print that one. So let's just go to the next one. As our class is going to be pretty straightforward today. So the next one is, we can also create array using another method that we call line space. This line space looks like a range, but it's not a range. It's not a range. What this line space does is that line space creates numbers from the start point and the end point, including the end point Unlike a range, we said the endpoint will not be included. But in line space, the endpoint will be included. Now, how does line space get its own next number? It gets its own number with a next number with a particular mathematics formula. For instance, now let me give a practical example. Let's say, based on this code now, I want to get a number between 1 and 100. I have to add 1 and I have to have 100. Then the third argument is set 5. It means I want to get 5 numbers. Not that I want to increase it. I want to increase each number by 5. No. I want to get 5 numbers. So how do I get 5 numbers that are between 1 and 10? This is the formula. 2, 4. Anyway, I'm not doing that in my head. So this is 3.25. Then we go again. 3.25 plus what? 2.25. And that's going to give us what? 0.5, sorry. 5.5. What again? 5.5 plus 2.25. 7.75. So 7.75 plus 2.25. That's 10. Does it sound right?
Yeah.
Is it correct?
We are supposed to have 5.
1, 2, 3, 4, 5.
Okay, we'll start from 1.
Yeah, one has to be there. The first digit has to be there.
Okay.
So that's just the formula there. It's not necessary we get the formula just to know how it works. So let's just move on. And that's what the code, the function is going to do behind the scene. What's this one? So let's just implement the function. So we want to get numbers that are having a particular range of intervals, but they are specific. They are not like they are being incremented by 1 or by 2 or something. So in case you have problem that requires this, let's see. Then we can say num is equal to np dot line space so let's say we have 1, we have 100, then we just want 5 of them. Let's say we want 10 of them. Well, we can say we want 10 of them too instead of 5. Then let's print this out. Then we can say print num. So we can see that the number is in float. We can change that to integer if we want. We can say the type case. Let's say the type equals to, I think it should be integer. I'm not sure if this code will work. Yeah, I think I'm correct. So we have 10 of them now, and it starts from 1, it ends with 100. In case you have question that requires this type of, NumPy array to work with. I would like to move on. So let's move to the next one. So we have what we call, okay, let's assume that we want to get some fixed values in our array. If you are dealing with deep neural network or machine learning specifically, there will be some case. For instance, if you want to train a neural network and you want to initialize value before you start doing the gradient descent or back propagation and the rest of them, you have to initialize your model to know where it is going to start before you start moving down to the bottom of your model to get the minimum value. I'm speaking in calculus and deep learning terms now, but don't worry. Anytime you are building machine learning or you want to train a model, there must always be a starting point. Sometimes if you want to start your model at a particular point, we normally use the concept of initializing it with a fixed value sometimes or random value sometimes. But most times we normally use fixed value and sometimes we use 0. And this is one of the methods we can use for that. We can use np.0. Type that now. You can just type that. You can use np.0. I will just type it straight away. You can say, okay, I would say this np.0, and that is, let's say I want 5 zeros. Let's say I want 5 zeros. Then you can see that this one is 5 zeros. Then you can also have np.1, the same thing. You can say print np.1. You can see the 0 is with s. Then you can also say ones. If I want 10 ones, don't forget that this number they are given as dots. They are given as what do you call it, decimal numbers. So you can change, it's float, yeah. You can change it to integer. You can see the way I change it to integer here. Yeah, you can change it to integer there. If you want it to be returned as integer instead of float, that's the second function. And the third function is, did I remember? No, I don't remember. Let me just check it. What's the third one? Okay, full. Okay. So this full function, I think this one is going to give a particular value that is different from 1 and 0 based on the number of dimensions you give it. Let me just write it. I don't think I remember the details of how it works now. np.full, F-U-L. Let's say I want 5. All the outputs to be 5, but I want them 7 times. Let's see if that's what's going to give me. I want 5 and I want them 7 times. Come on. Sorry. Yeah. I think that's rightly so. Now, when you are using full, it's different from you just want ones or 0. You can put any value here. The first argument is going to be the number you want to get out, which you want to be repeated. Okay, let's say I want 15 to be repeated 7 times, and that's the first argument is going to be what? Okay. I think I messed it up now. Yeah, the first argument is the number of times you want to repeat, and the second argument is the number that I want repeated. I think we will have to have break at some point to go and pray, but let's just continue for now. So do you understand? All the method is clear, right? So let's start. Because when you start using this thing in machine learning, then you will not be asking where did it come from or something like that. So let's just keep going like that. Okay. Let me go back to it. Anytime you want, we have talked about ones and zeros. They just print 1 and 0 for you. But if you want a particular constant value that is different from 1 and 0, then you can use this function, np.full. The first argument is going to be the number of times I want to repeat that value. Then the second argument, which you put comma in between, is what I want to repeat. If I change this one to 17 now, then of course I should have 17 repeated 15 times. Or change this one to 5, then I should have 17 repeated 5 times. Okay. So let's try to step deep into multi-dimensional array. Just like we have explained list in our last class, then we used 2-dimensional list to implement multiplication table. So the same understanding that we have there can also be used there. A multi-dimensional array is a 2-dimensional array. It can be 2-dimensional. It can be 3-dimensional. Yeah, just like we explained in the picture. It can be 3-dimensional if you have an image. If you snap an image that is colored now, it has 3 color channel. And we use this understanding in our convolutional neural network. So a multi-dimensional array can be implemented in Numpy. It can be 2-dimensional. It can be 3-dimensional. But how do you identify a multi-dimensional array? Look at it. Let's see. If you want to create a multi-dimensional array, you are going to say your np dot array. You are creating it using the function array. Then you have this. Then since you are creating your array, your numpy from list, most times we go to from list, you have your square bracket to represent the first list. If you remember in our class of the multiplication table, the 2 array that we create, when we create the 2-dimensional array, we use 2 square brackets. If you remember, if you can recollect from our multiplication table, each of the rows is put in square bracket by comma. Then you can have another comma. This is another row separately, and this can be another row. For instance, now we can say this one is how many rows? We have 3 rows because each of the square bracket is 1 row. This is 1 row. This is 1 row. This is 3 row. Like row. Like row. This is a square bracket. This is one row,
Yes.
this is another row, this is another row. Then we can have elements in them like this. Then this will now be column. And that's what we have here. So I've created 3 rows now. If I want to have my column, it's going to be based on the number of elements. So the column is going to be the one that is spanning this. Let me say I want to have 1, 2, 3 in the first column. That means I'm having in the first row, I have 3 elements. That's 3 columns. Then I can have 3 columns across. If I want to make a square matrix, for instance, what I mean by square matrix is that the number of rows is equal to the number of columns, mathematically speaking. So this 4, 5, 6. This 7, 8, 9, for instance. So I have created an array that has 3 rows and 3 columns. That is a multi-dimensional array. The one we first created up here is a one-dimensional array. I can bring this one and just put it here if I don't want to have it as a variable outside. I can put it here. It's still going to give me the same thing. Of course, that one is going to make noise. Let me just remove it. It's going to make noise here. Then, of course, I can just put the list directly in there. This is one-dimensional, just one row. So if you want to create more than 2 rows, you have to make sure that you put one bracket again. With this now, since I have 2 brackets, since I have 2 brackets here, this one has turned to 2-dimensional array. Yeah. If you see 2 brackets like that, 2-dimensional array.
So from the number of
Bracket, you can the number of array you are dealing with. Of course, we are still going to be talking about how to know the dimension of an array. We are going to be talking about that very soon. But one way to identify them is that if you see 2 brackets, 1 bracket outside, and each of them has bracket, so this is not one-dimensional again, it's more than 1. It might be 2, it might be 3. Yeah, it might be 3. If you have 3 brackets, 2, it might be 3. So let's print this out to see how it looks. And you can say print num. Then you can print, it's going to give us form of change spoken language. Okay, you have it in row like that. So each of them is in row like that. Okay, so let's move to another thing. So we have, what's this? Okay, if you want to measure the dimension of your array, there are some methods that we use for it. We have what we call size, we have shape, we have ending. All this method, all these functions, they will come handy when you start building complex model. For instance, if you are dealing with deep learning, then you know the purpose of this method. They are very important. Because when you are dealing with image, for instance, most times you will be stuck. If you don't know the structure or the shape of a particular array you are passing, especially when you are dealing with matrix multiplication. Multiplication in matrix has a basic rule. The number of columns of the first matrix must be equal to the number of rows of the second matrix if you are multiplying them. And we do multiplication most time when we are dealing with convolutional neural network. So this method, they are very, very important. So we have 3 of them. So with our multi-dimensional array that we have built now, let's say we want to check the shape of the array. When you say shape, it is the same thing as saying that how many rows by column does it have? That's the meaning of shape of an array. So if I have a table structure, an array that is table structure, I want to calculate or tell me how many rows does it have? Just like matrix. If you are familiar with matrix, we are just talking about matrix. How many rows do you have? Then how many columns do you have? Then if I type that now, it's going to give me the shape. Okay, let me just explain. Another one we will be using is size. Size is different from shape. The meaning of size is that, let's assume that I have this array now. This is like 3 rows, because this is 1, 2, 3 by 3 colon 1, 2, 3 by 3 colon. So this one will be written. This shape is going to return a tuple. There is what we call tuple. I think I talked about tuple. Yeah, it's kind of a constant kind of data structure that doesn't change compared to yeah. So this is 3. This is a tuple. It's going to return tuple that will be written like this, row by column. But the size is going to multiply them together. The size is going to tell us the total elements in it. What that means is that if I count this 1, 2, 3, 4, 5, 6, 7, 8, 9. How do you get that? You get that by saying 3 times 3, and that is 9. 9. It's going to give us 9. The size is going to give us the total elements in that array. And the third one I think we'll be using is ending. This one tells us what type of array are you dealing with. Is it a one-dimensional array? If it is one-dimensional array, it's going to give you 1D. If it is two-dimensional, I think it's just going to give you 2. Sorry. I think it's just going to give you 1. If it is one-dimensional, it's going to give you 1. If it is two-dimensional, it's going to give you 2. If it is three-dimensional, it's going to give you 3, I guess. So we are going to do the three method that we will use to check the structure of our array. So let's just implement that now. So let's see. I think it's still there. It's still there. Logo be over now. So let's see. Let's use the 3 now. We can say print. We are not doing anything complicated today. So let's say we want to check the shape of the array we have created. We will just say the array is being stored in a variable, and the name of that variable is num dot shape. I'm not sure if we are going to put this or not. Let's see. If it shouts, then we will remove it. Yeah, we are not going to put that. We won't put this. We just do this, and we have this. So as you can see now that we have the shape of the array to be 3 rows, which are each of the lists that are found separated by comma, and 3 columns, which are each of the elements that are found there. Then let's say we want to, yeah. No problem. Okay, I can. Okay, follow along. So I will just try to do a kind of repetition from the beginning again. This is what we are just done so far. What we are planning to do today is that we are trying to introduce the last 2 or the most important library we'll be using for our machine, and we'll be training our model starting from next class. So these are the 2 most important libraries. It's called Numpy and Pandas. Numpy and Pandas. The meaning of Numpy is numerical Python. Anything that has to do with computation, complex calculation in mathematics is being done faster with Numpy. And Pandas is table shape. If you are dealing with data science, anything that has to do with table, cleaning the data, visualizing the data, this is the library that they use for it. So that's the purpose of the 2. But we are starting with Numpy, and we are trying to understand what are the attributes, what are those things that we can use in Numpy. And we said that before we can understand Numpy, we have to go back to our understanding of list. We have talked about list, because we are going to be building Numpy from lists. And list is like a rectangular shape object, which we have discussed earlier on. And we are explaining some of the methods that we use with list. So I will just go back to them briefly. This is where we started. If you want to use Numpy, you have to introduce it with this. You have to import it in your program, because it's a library that is already in Python, but you have to import it with this. And the reason why we use as is just to have a short form instead of calling Numpy every time. That's just a standard way of writing it. Now, the first one we did is that if you want to grade Numpy from a list, I've complicated something here because I've explained beyond. Now, if you want to grade Numpy from a list, the first thing I said you do is I can say, okay, let me grade my list first, and I can grade my list by saying this is 1, 2, 3. 1, 2, 3. Then we have my list there. I'm coming, I will explain this now. Now, we are familiar with this before in our previous class. I've graded list. Then from this list, if I want to convert it to a Numpy, Numpy is built from array. So you will call this Numpy, which is NP, which is what we use to represent Numpy here. There is a dot array. Array is a method that will help us to convert the list to Numpy array. Then when I print it, if I print it now, I'm going to have a Numpy that will just appear as a list. It's just going to appear as but this one is not a list. The reason why you will know it's not a list is I try to check the type of data it is, which is what I did here. You see that this one it looks like the list we are familiar with, but it is not list. You should not confuse it with this. Then it tells me that this is a Numpy ND array. That's the data type, it's not a list. Then we move on. we move on to a range, like we use in our list. We use range in our list. The same understanding we use in our list to understand what we call range. Range is going to have the beginning, the start point, the end point, and increment based on what we have explained on range before. Then that was what we explained here. So if you want a great set of numbers that will have the beginning number, the end number, and they will be increasing by a particular number. If I want to get a set of even numbers now, just know that I can use a range for NumPy, or I can use range for list, something like that. If you have question, you will just know the one you have to use to solve that particular question. That's why I'm introducing this to you. Now, and that's what we did here. The starting point, the end point. Don't forget that in range, the end point will not be included in our calculation. And this is the increment. This one gives me number starting from 1, increasing by 2 until it gets to 10. It will not go to 11. Then I move on. This is another function that we can use with NumPy. We call it line space. And that's the calculation we did here. I almost forgot it. Now, it will look like a range, but it's not a range. It has start point, it has end point. In line space, it takes the end point into consideration. Unlike a range, we don't put 11 there. But in this case, the 100 has to be there. But one thing about line space is that this third argument is not directly being added to each element. No. To get the next item, that's the calculation there. The range, the maximum minus the minimum. I did an example there. Then we are going to say that number we use to increase, which is 5 in this case, minus 1. Then with that, we are going to be seeing the number we will be adding to each number. Unlike a range that you are adding maybe 1 or 2 and the rest of them. Do you understand? Okay. I'm trying to give an example of, okay, if I want to use a range now, let me say I have num equals to np dot a range. A range. This is the function that we are writing there. Then I'm having the start point, the end point. I need 10. I mean, the start point, the end point, and I need 5 of number between this range. I have 1, 2, 3, 4, 5, up to what? 10. But I need 5 of this number. That's what line space. Sorry. You can't correct me. It should be line space. Sorry. It should be line space, not a range. The start point, the end point, then I need 5 of this number. Now, to get the 5 of this number, we are going to get the range, which is maximum minus minimum, divided by this total. If I don't want 5, if I want 6 of it, I can put 6 here. Then that is going to be 6 minus 1. Then that's going to be the number which we call step that you will be adding to each of the number to get the next number in the sequence. It's just something like that. And that's what we implemented with this code. You can see that we started with 1, then we have the last number 100, then we want 10 of them. Then when you look at this, we have 10 of them here, 1, 2, 3, 4, up to 10. The last digit is included, unlike a range.
So when we count it, it's going to give us 10 and 11. I'm going to count 1 and
Of course, everything will be 10. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10, 10, 10. Yeah, let me, if I change this to 11 now, you see that it's going to give me 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I put this there because I don't want it to give me float number. I want it in integer, whole number, and that's why I put it there. Then 0, I want 5 zeros. In upper array 5 0, I want 10 ones, and that's what I have here. Then no, this one are different function entirely. This is 0. np.0 is a different function entirely. I want 0. Yeah, we use this when we are building neural network, for instance. That's when we use this. You might not use it necessarily now. Then we want 1. I want 10 ones, and full is going to give me value that are constant, unlike 1 and 0. Then I want 17 value that are 17. Give us the number of row, comma, the number of column, and that's a tuple. If you check the data type, you see that it's a tuple. But we are not going there. Let's just move to the next one. We are going to be using size. We need, yeah. Let me finish this one, then we will have a break. Yeah, it is. So let me finish this, then we'll have a break so that we'll convene later. So the next one is let's say we want to know the size of our numpy array. Come on, I don't like this. The size of our numpy array. Our numpy array that we are using is num dot size. You don't put the bracket in it. Yeah, and that's going to give me the size. The meaning of that size is the number of elements. If you count this 1, 2, 3, you will see that it is. Why is it 11? It should be 9. Don't mind it. It's doing something. It's doing something. It should be 9. The reason why it's doing that, maybe it has taken one num, because I'm using the same variable name for the rest for everything. So maybe it has taken the one ahead, something like that. That's why I have to run it again. Yeah, the first one is shape. The second one is size, which is going to calculate all the elements. Like 3 times 3 is 9.
What is shape?
Shape. That's number of row by number of column, like matrix,
Okay.
like table, row, column. Yeah, that shape. Then the third one we will be using is ending. So we have print. So we have num dot end dim. I hope I get it right. Okay. This one will tell us, is it one dimensional or is it two dimensional? Then you can see 2 here, which shows that it's 2 dimensional. So we have to